All right. So welcome to the CredC seminar series. Today we have Rob Lee, who's the CEO and founder of Dragos Incorporated. Rob's going to be presenting on the current threat landscape that we see in industrial control systems and where we're going from what we've seen today to what some of the gaps and methodologies moving forward are. Rob is pretty well known to the community, so I'm not going to go far into his bio, but as I mentioned, he's CEO of Dragos and also known as the author and brains behind the technical side of SCADA and Me. He's also a SANS instructor, has been recognized as an influencer in this space by SANS and Forbes, and does lots and lots of great work. So Rob's a really energetic gentleman. He came from a military background and enjoys the private industry and the ability to speak his mind. So strap in and we'll let Rob take it away.
I love that intro, Tim. The ability to speak his mind. Yeah, that's been my favorite part about being outside the government. Love my government folks and the work that's going on there, but the freedom of speech piece, to have it back is fun. So I really appreciate everybody joining me today. Really what we wanted to talk about is this idea of the industrial threat landscape and understanding what we have been seeing. And so really a major portion of my talk is going to be around where we are and where I think we're going. I did want to throw in some research ideas and things towards the end, because I know that's a big focus of the folks involved in CredC, which it's always nice for me to be slightly associated with CredC as well. An advisory position is usually the idea of trying to claim credit for things that other people do, but you don't really do much. So I always appreciate y'all letting me hang around, but I'm very excited about CredC and the research and work you guys do. It's a really, really good thing for the community. I think sometimes in research, it can be hard to see that. Hopefully it's not hard for you all, but the rest of the community sees it. So let's jump in. Really, as I said, I want to focus on some of the selected case studies. I want to talk about what is the strategic level issues that I see today for the ICS security community, and what are some of these lessons learned that we already have from the threats that we've seen, and some of the ideas about where we're heading. The recommendations at the end is pretty short. It's some generalized recommendations on things for research to tie into the CredC mission, but hopefully the discussion spurs more ideas than the slides at the end. So when I look at the threat landscape and I look at the ICS security community today, I really see two strategic challenges ahead of us. There's plenty of them, but two that I think are really going to be challenging. Number one is we just don't have a lot of people, and we all opine about that. And we oh yeah, well we got to train more people, and that's real. But there's a couple things to that lack of people that I think go undiscussed. One of the issues with not having a lot of people that are actually ICS and cybersecurity smart, so ICS cybersecurity specialists, the problem with not having a lot of those is there's a ton of interest in this space. There's a growing market and industry in this space, but there's not too many voices of reason. Now, we can all think of plenty that we know, and I think the Department of Homeland Security puts the ICS cybersecurity specialist, if you will, at around 500 in North America, and so it sounds like, wow, yeah, 500, we've come a long way. That's not a lot of people. And so it's an issue for scaling what works at customer sites and at asset owners and industry. But it's also the fact that, and I hate to say it, I mean, there's no other way to put it, but bluntly, is there's a lot of people who run their mouth who have no idea what they're talking about. And we see this consistently at conferences where somebody will stand up and educate asset owners in the industry on things that are more or less IT security best practices, copy and pasted into ICS. And that can be dangerous. So we really need to ground our understanding and research. We really need to ground our understanding of what works, and we need to get it out to those folks. We need to spread that knowledge. The second really large strategic challenge for me is if we're talking security, and we're not just talking hardening of systems, but you're talking security, you're talking about threats. I mean, there's a portion of that security discussion, a major portion, that deals with threats that are trying to break into facilities, either steal and do trade espionage, or maybe even some level of destruction or disruption. And The chart to the right is a chart from the ICS certs metrics. Now, we know the ICS cert is no longer a thing. It got rolled up into the NKIC. But for years, the ICS cert put out some metrics to the community. Media always over-highlighted the wrong aspects of the metrics. They said, 295 incidents this year. Well, that's not actually what was being tracked, and there's far more than 295. But okay, that's what got highlighted. But the one metric that was consistent every single year that never seemed to get highlighted, that I always found to be the most interesting, was that every single year, the number one attack vector into ICS was unknown. Every single year. And the number two was spearphishing. And everyone's like, yeah, that makes sense. No, it does not. We do not have a lot of email servers in SCADA and DCS environments. So what the metrics are actually saying is, if anybody saw it, it's because corporate caught it coming through IT. Otherwise, we have no idea how it got there. And if we're not really taking into consideration what the threats are really doing and how they're getting there, then I would position that we're not actually moving the community forward with regards to the threats, and we're definitely not learning and making ourselves better the next time around. This concept of the unknown threat landscape is something I've been harping on for a couple of years now, and we're getting a little bit better, and I'll talk about that in the next couple of slides. But it really goes back to an issue where we're looking at collection and analysis of data. If you look at the larger InfoSec threat landscape, you'll see that really good companies, Microsoft, Symantec, McAfee, FireEye, these folks have done a really good job over the years. CrowdStrike done a fantastic job of understanding the IT threat landscape. They come out with beautiful reports about the threats, how long they've been around, sites they've targeted, but that's because they have incident response data and they have collection from customer networks. Their endpoint protection systems, their firewalls, their antivirus, etc., in those environments beaconing back to them about intrusions and malware they see. That has never historically existed in ICS, sometimes with good reason, and so we've always had an issue of collection. That collection has led to some of that unknown threat landscape. The second piece, though, is even when cases occur, the skill set and knowledge of dealing with ICS anything wasn't always there, and that became another issue. This is very evident even in the reports that you've come to know very well. If you look at anything with cybersecurity, you remember the APT1 report by Mandiant, you remember the Dragonfly report by Symantec, and these offer kind of a juxtaposition between each other that's interesting, where the Mandiant APT report launched in early-ish 2000s, I think 2010, if I'm not mistaken, 2011, launched and stated, there was some targeting of energy companies, some targeting of petrochemical companies, but it was corporate. We'll actually know from the time that there was cases in the ICS, but it was just, again, an aspect of collection and getting that data. And at the time, Mandiant definitely didn't have like ICS people to go into those environments to try to see that. If we look at the difference with the Symantec report, Symantec put out a really good report called Dragonfly back in 2014, 2013, 2014 timeframe, and said, look, this is an energy targeted campaign, and talked about adversaries targeting the electric sector. And they did talk a little bit about ICS, but what they didn't do is they didn't highlight their collection biases. And actually we knew, had visibility of the fact that Dragonfly was targeting the mining industry, they were targeting the petrochemical industry, they were also targeting the manufacturing industry. But in Symantec's collection and their network and their ability to collect data, they were seeing electric providers, they were seeing energy focused. They didn't see the chemical manufacturing and the regular manufacturing because their clients didn't exist there. They didn't have as many clients there. So I'll position that a lot of the things that we hear and see are based on a collection bias where we highlight the things we see and are not so good as a community understanding what we don't see. So let's figure out where we are. When we look at what's going to be facing the ICS community coming forward, I will say that we are going to be in a position where it becomes, and so we need to balance this a little bit so we don't freak everybody out, but then we also take the threat seriously. And if we look back at 2010, 2012 timeframe, that's when most people learned that SCADA was a word when Stuxnet occurred. And Sandworm came around the same time and started using the Black Energy 2 and 3 malware to target energy companies in the West and specifically some other industries as well. And then in 2013, 2015, we saw, okay, well, sure, this Dragonfly campaign. So every year we usually talk about one. In 2017, there were 5 distinct groups that were targeting various industrial infrastructures, and now we're up to 7 groups with 10 campaigns. So 7 groups of actors with 10 distinguishable mission sets that we can sort of identify. We've also now gotten to the place where instead of one ICS tailored piece of malware, the original sort of S-word Stuxnet there, we're now up to 5 ICS tailored families of malware. CrashOverride, Trisis, Black32, Havocs, and Stuxnet. In the 2015-2017 timeframe, we also saw the first ever cyber attack on a power grid to take down operations. We saw the first ever malware to target human life. So let's jump into these case studies and think about some things that we learned that, again, we can apply towards what the research needs to be to limit down the risk of what we actually have going on in the community. To do this, I want us to use a model that Sergio Caltagirone made back in his time in the intelligence community called the Diamond model. So some of this stuff is just coming to the public in terms of, not the Diamond model, it's been around forever, but sort of people's backgrounds. So I used to not go around and tell people like, oh, I used to be at the NSA. Like that was not a common thing. There are a variety of leaks. People have been getting tagged as related to the organization though. So Sergio had been tagged as related to it as well. So I'll sort of go into his background. Sergio was one of the original threat analysts over at the NSA when they were building out their threat operations center. One of the founding members, and dealt with the various nation states breaking into government networks. And what he ended up doing, sort of trial by fire, was creating this model to be able to distinguish activity from each other. So a campaign, that's kind of a dirty word. We're not going to go too much in here, but a campaign is kind of a dirty word because it's technically a mission focus of the adversary, and you don't exactly know what their mission focus is. You just have an assessment based on collection. But to go back to the Diamond model, this is something that we can actually sit down and have a good discussion on to say, well, what was the infrastructure the adversary using? What was their capability or their tradecraft? What was the victim? And that gives us an understanding about the adversary. Not necessarily who they are, but we can clump them together as some made-up name to say that there's a human threat, they're a human activity group, if you will, focused on us. And if you have distinguishable characteristics in the Diamond model from a different set of activity, different set of intrusions, we can define this as a different activity group. So this is how threat intelligence is done. Threat intelligence is not indicators of compromise. It's not feeds. Real threat intelligence is analysis of adversary capabilities and tradecraft and victimology. And so we're able to come up with this view. Microsoft positions that there's around 320 activity groups active in the world at any given time. They position that really only about 60 of them are traditionally active in your region of the world. In fact, a lot of these things tend to be geopolitical. You might ask, why don't we see more Pakistani, advanced persistent threats? Because we're not an Indian energy company, right? Some of these things can be fairly geopolitical in nature. But the tradecraft, the methods that Pakistani group uses might be really important for our U.S. infrastructure owners to understand how these break-ins are occurring, even though they don't necessarily care about specific vulnerabilities, exploits, malware, et cetera. The methods and the tradecraft are usually pretty important. So my company, we keep track of the different ICS threats. Even though there's around 320 threats at large, there's probably only 30 to 40 that really target infrastructure companies at all. And right now we're only tracking 7 that specifically target industrial networks, so the ICS components of those companies. So if we look at that first one and sort of consider this as like your threat brief, we track a team called Electrum, which has links to the Sandworm team, but it's more likely that they're actually the development team for Sandworm, so making the capabilities that Sandworm leverages. And we can look at some of the things about them that are interesting. We can look at the fact that they use dual hone infrastructure, such as legitimate communications and internal proxies that they set up with deep inside of the networks that they're in. They're targeting specifically electric and water utilities in Ukraine right now, as far as we can tell. And that they're working on and have developed and deployed various capabilities such as CrashOverride, which was an ICS-specific capability designed to disrupt the electric power grid in Ukraine in 2016. Now, you'll notice there something different, and this isn't too key for this discussion, but I think it's key as you go out and talk about threats in the world, and that is right down the bottom it says Russian state interests. The larger security community loves to run amok with attribution and say like, it was the Russians, it was the Iranians. And actually, although that's doable, I would position that it's actually kind of useless. For a security team to think about attribution guides and biases the way they do their investigation, and it's actually a harmful thing. However, one of the aspects of attribution that can be useful is prioritization. So if you're a U.S. electric company and you have tension with North Korea right now, and a North Korean group has emerged, you might prioritize the tradecraft of that North Korean group. But I would further position it doesn't actually matter if they're North Korean. So let's back up this almost confusingly sound topic to explain this. If I build a model of what I think North Korean state interests are, like targeting U.S. electric utilities during tension, if I build that intelligence model to say this is what I perceive and I analyze North Korean state interest to be, then as long as I can effectively use that model, and I say, okay, Kovac is a North Korean state actor or North Korean state interests, they fit into this model, so I'm going to prioritize them. As long as I've done that correctly, it doesn't actually matter if the team is North Korean or Syrian. As long as I've been able to effectively create a model of what I perceive to be state interests and use that to prioritize defense, the real attribution behind the scenes doesn't matter. So this is where I think the community needs to grow up a little bit, because this is the way that we did it in the intelligence community and works very, very well. But the reason people love to get to attribution is because it gets you front page stories in media, and that's not necessarily the appropriate way to do it. So state interest and understanding that that does not necessarily mean Electrum is Russia, it just means they're operating the ways that we perceive the Russian state to operate. So that's our first one. We look at Dimalloy. The interesting things here is they have links to what was called Dragonfly 2.0, but we actually took a look at the Dragonfly 2.0 data set from what we could acquire, and found that Dragonfly 2.0 is not Dragonfly 1. And so some of the research that came out from others positioned that there was Dragonfly 2.0, and then there's this Palmetto fusion campaign that hit the energy sector in the beginning of 2017. And you know what? They're all the same. And so they got wrapped up, and even in some DHS announcements and Symantec announcements, as one activity group, as one group focused on the energy sector. When in reality, we can break it out and show that there are three distinct groups. You wouldn't want to prioritize how you're doing defense as if it was one adversary when it was actually in three. So we can learn from that. We can actually find that it's not only Western Europe electric operators and North America electric operators, but larger Turkish energy operators and providers. But we also see a lot of the stuff they're doing tends to be publicly available tools. No cool 0 days and sweet things there, but a lot of using what's readily available. And this tends to be a trend with adversaries, to do whatever is achievable instead of trying to be fancy. Early 2000s discussion were all about nation states using 0 days and custom malware, but there's no bonus points for looking good to a defender. The point of an adversary operation is to achieve success. So if you can do so without wasting tools and burning capabilities, then of course you would. It makes a good return on investment discussion. We also have Chrysene active right now, but they're largely focused on the Arabian Gulf and Saudi Arabia. They have done some targeting in the U.S., but interestingly enough, the aspect of their targeting is still tied to Saudi Arabian companies that do things with oil and gas, maybe abroad as well. With them, they do have some ties to that oil rig actor that I think Palo Alto put out, their intel team. And we start seeing some different ways of communicating in and out of ICS environments, including DNS. And so we think, well, does ICS really have DNS? And in fact, actually quite a few ICS environments have DNS. If you look at the Profinet protocol as an example and Profinet systems, you'll find that a lot of system information is actually stored in a DNS server when you look at Profinet installs. Not always, but in many cases they are. So we have to start thinking about, if an adversary is using something and doesn't fit our model of why that might be in an ICS, we might need to look a little bit harder and find that, in fact, the ICS isn't as static as we might have thought it was. McNally, another group, this one has done some interesting activity, still targeted towards aerospace and Saudi Arabian petrochemical. Now, they have started targeting outside of petrochemical, but only for North American and South Korean targets that we see that have Saudi business. So this is where that prioritization can take place. On if you're a company, if you're an ICS company, say you're an oil company that is doing business with Saudi Aramco, then you might prioritize McNally into actually being in your threat model and understanding that they might in fact target you. And again, a lot of this has been commodity and non-public malware. And with some of these and a couple of these slides, really what I'm highlighting is, although we tend to prioritize the ICS malware, CrashOverride, Trisis, etc., it turns out that more often than not, people are using traditional IT malware to get into these environments, and then they're not really needing malware capabilities in the ICS itself. They're largely abusing native functionality, a term that we often refer to as living on the land. So they're using functionality that already exists in those networks. And if you have a Windows 10 HMI and it's got PowerShell on it, you can rest assured that it's going to be abused before some custom malware gets loaded. I had mentioned Kovac earlier, so this is an interesting one targeting electric utilities in the U.S. We see them spike in activity every time there's some level of tension between North Korea and the U.S. And this is the one that also scared some folks this previous year, where they were specifically going into ICS environments and taking HMI screenshots and exfiltrating them out of environments. The reason that bothers people is when we think about an ICS attack, we generally think about attacks versus intelligence versus espionage. And if you're stealing off trade secrets, that doesn't necessarily equate to later destruction or disruption. But if you're stealing off engineering workstation documents, if you're stealing off design documents, data storing information, screenshots of HMIs, etc., then there's concern that you might be looking to develop or design a capability or operation to do some level of disruption. The type of data that people steal can be very indicative of the potential future intentions that they have. Cool. So those were all an abstract kind of view of threats. Let's talk about specific case studies, which I think brings all this to be a little bit more tangible. So I was not involved in this one directly. I was still at the NSA at the time, while the NSA had built and led a mission to look at the nation states breaking into industrial. So I had some behind-the-scenes knowledge on this one, but I wasn't involved in the incident response at all. But in 2014, the German government came out and said, look, there was a massive damage in a steel facility due to a cyber attack. And there's never really been a lot of public details on this, but I want to go into some things and say that in my understanding of the case and in the analysis I've been able to do on the data present, malware was used to get into the IT networks, but it was just VPNs and connections into the ICS that was used once the adversaries were there. Going back to that living on the land discussion, at no point did the adversary create and deploy ICS-tailored malware in the ICS. It was very much a get connections into the environment, and in my assessment, it didn't even look like they intended to cause damage. It looks like they were there stealing off trade secrets related to steel production, and they accidentally, may have tripped over some sensitive components that made it where the operators couldn't shut down the plant in a combined and controlled way. For upwards of a month or two, it's my understanding of the situation that the plant actually thought it was a maintenance issue. They thought the damage that occurred was specifically because of maintenance. They had no idea that there was a cyber component to it. And it wasn't until a follow-on investigation, again, a month or two later, that they determined that there actually was a cyber nexus to this whole thing, which goes to a discussion of root cause analysis. And this is an area that I think we must get better as a community. It's one area for good research, is how do you really get root cause analysis in an ICS to determine the difference between a maintenance issue and a cyber effect? And how do you know what's actually occurring so the right response plans can take place? This is a topic we'll hit on in a couple of slides as well, because you will have your physical response plans and disaster recovery plans at a facility, but you need to include that cyber component of them if you're going to have a good understanding of the events that are befalling you, because your own response plans can be used against you. Like I said, we'll highlight that in a slide or two. The next attack, this one I did get to be involved in, was one of the lead investigators for it with Mike Asante and Tim Conway. And in 2015, in December, effectively, an adversary turned out the lights in 3 regions of Ukraine. The interesting thing here was they were there for months. They were learning the environments and getting access to those environments, and they were in the IT networks for only a couple of days, but once they gained access, they pivoted into the ICS through the VPNs, and they were there for, again, months, learning and figuring out this environment. Ultimately, the attack itself, though, wasn't malware-based. They used malware to amplify their attack. They deleted the Windows systems and caused, bricking of serial Ethernet devices. But the attack itself, the power outage itself, was just them learning how to operate the distribution management system and using it against itself. So sending legitimate communications and commands to be able to open up the circuit breakers and take down the power. I have since seen quite a bit of discussion around limiting the functionality of these ICS, and I would caution us not to go too far, because you want your operators to be able to turn on and off the power. There might be some limiting that can be done, but that is not a vulnerability to be fixed. That's just a reality of the systems we operate. I've seen a lot of well-intended, ill-guided research focused on protocols that lock down functionality where operators couldn't do this at scale, or various other scenarios where enough thought process you can devise those scenarios where operators would need that. But the benefit and the opportunity for security was not at the final stages of the attack. It was in everything that led up to it. It was the fact that once they got into the ICS, they were still there for upwards of 6 months, learning the environment, doing lateral movement, interacting with the DMS, tons of opportunities to do defense. It's not the limiting of the final attack that we need to be concerned with. It's in the visibility and the response to the activity leading up to the attack, where we have some good opportunity without limiting operations. In 2016, as I mentioned, that crash override capability, so that occurred in December as well. And what was interesting about this was all of the knowledge of the 2015 attack was basically codified into software, made into malware. In my investigation of the 2015 data, I assessed that there was probably around 23 people that were active in that operation. That's a lot of people, because you also got to realize that even your adversary has PowerPoint and management. So 23 people on keyboard equates to a back office of HR and finance and people like that. So you're talking about a well-funded organization. But turn around in 2016, and you can actually deploy crash override once you're actually in the environment with a single person. And so it creates a scalability that was previously not attainable into causing power outages. And again, it's just using native functionality, the ability to speak the industrial protocols native in that environment, and to be able to open up circuit breakers and cycle through the circuit breakers to achieve that. So nothing that would have the typical IT focus of malware, exploits, and vulnerability. Really, again, we're talking about an adversary getting in position and doing native functionality. Now, the latest one that my firm has been involved with is called Trisis, and this one is particularly concerning to me. It's not massive power outages or things like that, but we're specifically talking about human life at this point. So in effect, what happened is over the summer in 2017, a petrochemical facility was attacked and operations were brought down, and that's how they knew that something was wrong. But upon our analysis, so it was Dragos, FireEye, and Schneider Electric all published analysis. FireEye called it Triton. So we all independently found and analyzed this thing, and what we learned was that the malware was specifically targeting the safety instrumented system. So if you're not familiar, an SIS, specific type of control system, purposely designed for a specific industrial process to make it safe. If you're going after a safety system, you either intend to kill people or you're just okay with it, because that's the entire functionality of the SIS. It's not there to protect your equipment. That's just protection equipment. It is there to protect people. And so the adversary behind Trisis developed a capability that would have gained access to the SIS and allowed them to remove the safety logic without interrupting the SIS. So in other words, they could have attacked it where everything would have been still running and normal looking, but the safety logic would have been gone, so that the ICS would have then been in an unsafe state if something were else to occur. This would have allowed them to follow up on the DCS to do an attack that would have resulted in death of people in that facility. That's an extremely, extremely concerning scenario, and one that I don't think we should take lightly. The interesting thing, though, is the adversary messed up. And so we know they messed up. We actually analyzed the code and found exactly where they messed up. Of course, we don't want to advertise out exactly how they messed up, but they messed up, and that caused the ICS to trip, because the SIS tripped because it detected something was weird or wrong, and so it brought down the operations around it. Again, if it would have been successful, everything would have looked normal, and they could have followed up with a second attack. It's sort of this multi-staged attack, if you will. This is still ongoing for them, and the actors behind Trisis, we're still tracking and have found them in other locations. So this is not an isolated event. This is a reality that I think people are going to have to accept as something that we're going to have to deal with going forward. And largely, as I bring down this discussion towards the end of my threat brief here, and we get into sort of the recommendations pieces, I would position that a lot of the things that we've positioned to the ICS community has been IT security best practices. Cyber hygiene. I don't know how many times I hear somebody argue and say, well, if we just did cyber hygiene, we'd be okay. If they just put two-form authentication on the VPNs in Ukraine, they wouldn't have been attacked. And that's actually not true in the slightest. We want to do the basics. We want to bring up the bar, and two-form authentication of VPNs and great control. But if you change the environment, the attack would have looked different. We can't really play hindsight bias on attacks and pretend that if we change the landscape, the adversary would have remained static. It's the same way that we can't look at our own environments against what's happening overseas and say, oh, well, we're so much better and that attack wouldn't work against us, because, again, those attacks are going to be different. To sort of highlight this, I've always been interested with the ICS patching, and it was actually Dale Peterson years ago that made a comment to me about the effectiveness of patching in ICS and noted that it wasn't all that effective at all. So I wanted to know exactly how ineffective it was. And so my team, and the links down the bottom, we just research reports free to download, but we wanted to put metrics to this discussion. So we looked at the vulnerabilities, threats, and sort of our incident response lessons learned over the past year in 2017, and said, okay, let's figure out what's going on. And one of the reports was specifically focused on vulnerabilities and found that 64% of all the vulnerabilities did not eliminate any risk if you were to address them. What that means, if you were to patch that vulnerability, it would put you in no better situation than you were previously in. Because many of them, actually 64% of these vulnerabilities, were really like stunt hacking. It was the idea that, like, one of them was, if you have physical access to the HMI and you do this vulnerability, then you can exploit it to get access to a PLC. It's like, dude, if you already have physical access to the HMI, you don't need an exploit to get to that PLC. You're already there. Also, if you access the HMI, you already, by various nature, have access to the PLC. So there are vulnerabilities that just are wasting resources. And we found that 72% of the vulnerabilities, including those 64%, 72% of them provided no mitigation besides patching. So this idea that industrial asset owners and operators, that your only option was to patch, when that's not even really reducing the risk. We furthermore found an interesting metric that we didn't publicly put out, but one that we're kind of talking behind the scenes to, not throw shade at too many people. But we found that 75% of all of the ICS vulnerabilities that came out are wrong. Now, I want to pause there for a second. Wrong. What do I mean by wrong? I mean, they were talking about the wrong exploit. They were talking about the wrong vulnerability. They were talking about the wrong PLC. They were talking about the wrong software, hardware. Something in the advisory was actually just wrong. So if you tried to use it at all, you weren't even reducing the risk of the right component, because you probably weren't even addressing the right vulnerability. So we've got to do better in that space. We've also got to be careful in what we're telling our asset owners. If you go to an industrial asset owner and operator and say, why don't you just patch your system? Well, again, it turns out more than half the time that's not helping them at all. Now, I'm not saying don't patch. I'm saying we have to be smart about how we do it and prioritize the ones that actually do matter and do impose risk. As an example, 15% of those vulnerabilities were able to gain access from corporate into an ICS environment, or from the internet into ICS. Well, that's a pretty big deal. The ability to break into the ICS in the first place and then be able to take advantage of the functionality that's there, well, that 15% might be something that we actually prioritize. But the idea, again, we can't just patch things away. So in the last portion of our presentation here, let's talk about where we're heading. And specifically,
what I think in sort of a macro level is some concerns that I have for where we're going as a community. I found it a little bit difficult to make this portion of the presentation. There's nothing particularly exciting, I don't think, in these next couple slides. I think it's useful, but I don't think it's groundbreaking. But why I found it kind of difficult is many of the things that we'd always positioned as big concerns have already happened now. Targeting of an SIS specifically to keep the SIS in functionality, but to lose its safety functionality was something that Mike Asante and Tim Conway and I talked about a decade ago, and we're concerned, highly concerned about. But we were like, well, hopefully that doesn't happen, and here we are. So I found it difficult for that reason. I also found it difficult because I don't want to exactly advertise out like, here's how I would take down a major portion of infrastructure. It's not exactly what I want to put in PowerPoint, but let's have a discussion. So the first thing that I think we have to be aware of where we're going and what we're going to see is, of course, we're going to have this increase in ICS and incidental impacts. We saw this with WannaCry and NotPetya taking down, American Maersk. People are not talking about this too much publicly, but it took down way more infrastructure than people realize. This wormable malware that spread throughout industrial environments because people still think for some reason that ICS are segmented. Oh, well, we're air gapped or we're segmented for some reason is still an argument that people have, when in reality it's just not true. If you're not in a nuclear environment, it is very rare and very uncommon and unlikely that you are highly segmented, let alone air gapped. We have business processes that need to pull data in and out. We can't just slap a data diode on it and pretend we're done. We have data coming in and out for business purposes, let alone optimization purposes. So we have these connections. I'm concerned in the incidental impact category of more vulnerable events that just spike resource usage and can cause issues. But what I would highlight here is I'm also concerned that we're going to over focus on these. So this is where some of that quote unquote cyber hygiene stuff can matter of, hey, you're still using SMB version 1, we can do better as a community, and that would cause that ransomware worm not to be impactful to you. And those are good things to do, and there's a lot of risk tied to those that we can help reduce. But I'm much more concerned with ICS tailored malware and campaigns. I actually don't think that we will have a giant spike in ICS malware. I think we'll have a giant spike in ICS tailored groups that know how to use our systems against themselves, because there's actually much more value in doing that than in developing malware specifically. But we're seeing an evolution from where Black Energy 2 and Havex were really about understanding protocols and things like OPC, to where we got down to CrashOverride, understanding understanding protocols and the systems they were using, like PLCs, down to the point of trices where we're saying process level knowledge of understanding that specific safety system and deployed in that specific environment with an understanding of the physical process and how to cause damage and destruction. If you got protocol knowledge down pat, you can do a lot of espionage. If you can get system knowledge down pat, you can do some pretty good disruption. But if you get physical process knowledge down pat, you can do physical destruction. And these are the things that we have to consider, because they are going to be more of those high impact, low frequency events that I think are going to be far more critical for the community than these incidental type cases. Even outside of destruction and disruption, which national security folks care about, we are seeing a significant amount of trade secret loss, where your big food and beverage company doesn't store the trade secrets for their recipes in corporate. They store them and loading them onto the logic on the controllers and the data historians and in the industrial environment. So your espionage has moved already and will continue to move into the ICS portions of our networks. The other things that I think we'll have to be very careful of is these multi-phase attacks. So over on the left is the ICS cyber kill chain. Over on the right is just the stage 2 portion of it drawn out. And this is a paper that Mike Asante and I wrote years ago about how high confidence process manipulation or destruction attacks work. But what I mean by multi-phase attacks is not multi-stage. Multi-stage would be stage 1, stage 2. Stage 1 is your traditional get into the environment. Stage 2 is the actual attack. What I mean by multi-phase is using multiple of these kill chains. So you'll do a stage 1 and stage 2, but you might have multiple stage 2s. So an adversary, to bring this to light, an adversary might break into an environment through stage 1, that drop a phishing email, drop malware, get a VPN access, get into this environment. But there might be multiple stage 2s they do where they develop different types of capabilities or knowledge sets or target industrial environments. As an example, and this is the one I alluded to in Trisis, where an actor would do a stage 2 effect against the SIS, but also do a stage 2 effect against the DCS. That way, the SIS is really just sort of an enabling attack for doing the type of attack on the DCS that would kill people. So I highlighted that stage 2 over the side because this is something that we've already warned about. And so Mike and I specifically highlighted this in our paper, saying, look, the ability to do enabling, initiating, and supporting attacks can snowball the effect of any given attack to make it where we're talking about significant destruction or significant loss of life. And I'm not a big fan of the hyped up scenarios like the power grid is going to come down. Like I didn't enjoy the Ted Koppel book. I much more of a realist than that. But there are significant destructive events that we have to be concerned with. And when I look at where we're going, I am particularly concerned of our adversaries learning off of each other and combining styles of attacks. So imagine, as an example, somebody goes in and does a Trisis-like effect, because it's not about the malware, where it's about the tradecraft, but a Trisis-like tradecraft against an SIS. They deploy a CrashOverride-like capability against the normal ICS, and then they do a 2015 style attack of misusing the system without ICS specific malware. So the problem there is now your incident responders and your investigation is focused on one thing. Very rarely do we think about multiple scenarios ongoing at the same time. And that light touch interaction on the first kind of visible thing, which would be the 2015 style attack, might be to try to recover the ICS and get it into a state condition and disconnect from the network as much as possible. But that in itself might be able to then trigger the second stage effect, which might then in that case take down an SIS, to then trigger the third stage effect, which would be able to take down the DCS or the larger ICS in a way that was larger than initially possible with any one of those attacks. So without going too off the rails here, I'll give it a more tangible example. In the 2016 attack, there was a big concern for Ukraine of following the normal incident response procedures and assuming from a disaster recovery perspective that the loss of power was not a cyber attack. And there was a concern that many of us had that if the operators would have ignored the cyber component or not understood there was a quote unquote cyber component, then they could have reconnected the equipment under load, which instead of an hour of outage would have resulted in weeks or a month of outages due to physical destruction of that equipment. So the idea of not having root cause analysis and responding to an attack is my big concern. I don't think we as a community are in any way prepared for that. We are starting, I'm a big defense fan. I think defense has the upper hand. I think if any community is going to solve it, it's the ICS community. And I think many of the hyped out stories that I hear in the media are just trash. That being said, we don't have many trained incident responders for ICS environments that know how to do ICS investigations to get to root cause analysis. We definitely don't have people that have ever really trained to or ever really experienced multi-phase attacks where there's not just one thing going on, but 2 or 3 targeted effects in an ICS. This fighting while under attack kind of scenario is something that does give me a lot of concern. I think there is a significant area for research to help prepare us for dealing with multiple things ongoing at once. Cool. So what are some research ideas? I think I'm running out of time here, so go ahead and finish it down before Tim yells at me. But let's talk about the research ideas itself. And these were, again, hopefully you took a lot of research ideas out of the first portion of the talk. These are just some things that they're against the wall that I think are interesting.
Number one, make sure you satisfy the right requirements. I think a lot of the IT mindset is to figure out adversary dwell time, or ADT, and try to figure out how to find and kick the adversary out of the environment faster. Most plant managers I talk to and work with really care much more about MTTR and RCA, which mean mean time to recovery and root cause analysis. How do we get the operations back up and running, or be in a steady state as they appropriately should be before the attack? And that's not a CIA triad availability kind of discussion. That's a model that does not apply here at all. It is a discussion of requirements at a mission-focused environment. The mission is not security. The mission is the widget you're producing, or the electricity you're transmitting, or whatever. And you'll find in working cases, and I've worked plenty of these incident response cases where we've gone in and found that it was just random malware, and it wasn't spreading and it wasn't causing risk. So we just left it, and the operators cleaned it up on the next maintenance cycle. And that was the appropriate decision for that environment. In IT, that would freak people out. In ICS, it made perfect sense. So you got to make sure you satisfy the right requirements. So let's talk about a couple problems that I see outside of the lack of threat knowledge and the lack of incident response skill sets. I'm first and foremost starting to see a rush for sensors. So as these startups come up and as these technologies come to the market, everybody wants to put another sensor in the substation. Everybody wants to put another sensor down in the DCS. These 1U network appliances or NUCs or anything else, they want to put some other hardware. And the problem is it's untenable. It's not supportable at all. We can't keep putting more and more and more and more things into the ICS. I would very much, actually, I'll get to the ideas afterwards, but let's start with problems. Problem is your energy company, as an example, has their own internal political capital. For a person on the IT security team or even the OT security team to convince the plant manager to allow them to go put some new hardware with software that they can't really explain inside the cogen facility or out the substation is already difficult. For you to ask them to do that 5 or 6 times, it is just not supportable. Another problem we have is an overfocus on malware vulnerabilities and exploits. I see this discussion all the time, and it's completely out of line with the threats that we're actually seeing. Most of the threats we're seeing are doing more living on the land and more misuse of ICS communications and misuse of ICS functionality than they are developing unique exploits and vulnerabilities. It doesn't mean this is bad research, it's just the overfocus of it is out of tune with the risk that we actually face. Another problem I see is an over-focus on machine learning and AI models. The idea that we can develop a machine learning model or anomaly detection to identify something weird largely, again, misunderstands the problems. So it's not that finding weirdness is bad, it's that the whole problem with that in the context of threats is a person is going to need to pick up that anomaly, add threat context to it of like, what are they looking at and why does it matter? And then having to run the investigation themselves. So an over focus on just a machine learning model may sound really scalable, but the problem is it puts 100% of the investigation on the security analyst. And we've already said we don't have a lot of those. So it's making boxes that are going to be chirping a lot, regardless of how effective they are, without the workforce and the skills behind it to be able to use this for security. In my opinion, in my experience, machine learning models and anomaly detection is a very poor threat detection. It's great for amplification. Once you have threat detection, to further highlight what's important can be extremely useful. But it's a very poor beginning stage of threat detection because of those 2 challenges I mentioned about the people. The next ones that need to scale that knowledge and workforce. We do have good incident response teams and people that are getting a lot of experience in the field these days, but they're still limited in numbers, and we need to make sure that we scale that knowledge that they have out into the workforce, not just through training, but through the technologies and processes and things we're creating. This also goes to a discussion of compliance, regulation, and frameworks, where a lot of the frameworks and things that I see published are, again, kind of out of tune with what we're actually experiencing from the threat component. And then the other problem I see in the community is we generally go through these 15 to 20 year life cycles, which everybody appreciates, but it also means major architecture changes. And it's not 15 or 20 years from now, it's every year at some plant, but not again until 15 or 20 years. So these larger companies have major DCS and ICS and SCADA rehauls all the time. It's just different, per plant. And as those major architectures change, our technologies, our models, our people, our structures have to be willing to adapt. And it can't be focused on, look, I've got this really deep, packet inspection when I change all of my protocols and all of my systems and all my physical process in a year. We've got to be able to be adaptive in how we approach these problems. And we need to make sure we put more human focus instead of just, again, that kind of model focus. Some ideas along that, and really, this is where you all can take it and run with it. But common robust dynamic sensor, in other words, something that people can use and deploy on the site that actually has enough computing power to support Docker images from various companies and softwares and technology. This is an idea that a number of private sector companies already have and they're working towards. The problem with many of the private sector companies is always a discussion of intellectual property ownership and, hey, I don't want to put my IP on your box where you can see it. So something more academic in nature or maybe even government supported could actually probably help with that. The limiting of impact outside of scope. So really, again, it's not always about stopping the thing from happening or exploiting this. It's about understanding how can we get and complete an investigation as quickly as possible so that we limit the impact. So it's not about stopping all the attacks, it's about reducing mean time to recovery. Instead of the overfocus on machine learning models, even though they have a place in the community, I would highly encourage folks to look at intelligence-driven approaches to understand what are the threats actually doing and how are we actually reducing the real risk we're seeing, and making sure our technology is in line with that. At the same time, being able to enable and scale the human knowledge we have through software. It's the only way I think we can do it. And then down towards the end on the larger architecture challenges, some of those can be completely sidestepped with common logging and API interfacing into the original equipment manufacturer's gear. So if Siemens, Honeywell, Schneider, Schweitzer, et cetera, all have common enough logging formats off their controllers, then you can actually abstract away the changing of the architecture to where it doesn't impact the larger security that you put around it when architecture changes happen, or common APIs to be able to pull that kind of stuff off. And that's going to be a longer project to encourage the OEMs, I think is incredibly useful to the larger community. So there you have it. I'm going to open it up for questions now. Tim, how much time do we have? I think it's just a couple minutes, but I'll leave it to you to MC. Oh, you're running up. You had no idea it was going to close. Oh, this is awkward. Oh, here he comes. Ladies and gentlemen, Tim.
Sorry. So, Rob, we definitely can take some Q&A. If you'd like, maybe go back to your ideas slide, and I'll start with Q&A. And there might be some questions from the audience too. So, I think all of the things you talked about here are great in terms of the approach, and some of them we've seen traction on already with implementation in a variety of different ways. But I wanted to hone in on one, which is intelligence-driven approach. How do you see that working moving forward? Do you think that that's something that can scale and that utilities and other asset owners could adopt today?
Yeah, absolutely. And I think not only can it scale, it actually scales, in my opinion, better, because when we see right now, we see asset owners and utilities constantly giving feedback that one of their biggest issues is every single person that comes to them has a different idea about what security looks like. And so they're getting hit with a myriad of consultants and government folks and FBI and DHS and academia and everybody telling them, well, if you only did this, you'd be fine. And we could all sit around and argue about those ideas, and they all come from a place of good intentions. Or we could say, well, here's what the threats are actually doing. And so I think that intelligence-driven approach actually hones in the conversation quite nicely to say, okay, electric utility, what's your actual threat model? And an electric utility could say, we're really concerned about VPN connections into our HMIs that can be used for a SCADA hijack scenario like the 2015 attack. And then the ideas can then be honed in to say, okay, DHS, FBI, academia, industry, et cetera, here's our requirement. Now, how do you want us to fix that one? And so I think taking that intelligence-driven approach actually focuses the conversation quite nicely.
Yeah, I concur with that. I think one of the problems, though, is that that loop has to close quickly in order to address the problems of the utilities, and it also, in theory, would be based on existing methodology that's in play rather than being proactive to eliminate future threats. So it all depends on how it's formed.
Well, absolutely. But this is also where I think a lot of people think of intelligence as indicators and information sharing, and it's not. And this is where a good example was being Kovac taking the HMI screenshots and DNS exfiltrating them out of environments. That tradecraft was also used by Down Alloy. So even though it seems like, oh, if I fix that, it's reactive, actually tradecraft is quite difficult to change for adversaries and has a very proactive nature to it. Indicator sharing, information sharing, etc., I completely agree. Very limited in nature, very limited in duration. Tradecraft scales quite well.
Sure. So we do have a question from the audience, if you want to turn your mic on.
I know in a lot of industrial and technical markets, Windows-based operating systems have taken over from formerly more secure Unix-based environments have been dominated. Is there any thought to working with the ICS or SCADA vendors to build their products or rebuild their products on more secure and manageable foundations?
So the Windows architecture is definitely more common now. I would vehemently argue that Unix is more secure, and I am concerned though with the functionality we are putting in. So a Windows-based operating system doesn't bother me, but a Windows-based operating system that still has Paint and Solitaire running on it that you can run on an ICS is silly. So we definitely need to limit down code access. We need to limit the information attack space. But I'm actually not concerned with the availability of Windows operating systems at the OT layer. What that's actually driven is more commonality to do a level of security across the OEMs where they previously had to tailor every single thing. It was another issue that they had around patching where they had every different Unix, flavor to customize. It was very difficult to figure out and test the patches against them. As they've moved to more common platforms, it's become more scalable to do. However, it still has a negative connotation to have anything common, whether it's Unix or Windows. The more common your architecture is, the less resistance there is for an adversary to have to learn it. So it's sort of shortening the life cycle a little bit of what the adversary would have to learn. And that's also where we need to add complexity in the form of security.
Thank you, Rob. Any last parting wisdom you'd like to leave with the audience?
Nope. I mean, my wisdom is bound to thanks for what y'all are doing. I think research plays a good focus in this. I would highly encourage you to keep an eye on the market. It's moving faster now than it ever has before. So things that were an area where the market didn't exist a year ago and some good research started is an area that we already have technologies and things in the market. Industry moves pretty quickly. So being in tune with that is going to be important to make sure the CredC mission aligns and moves us forward as a community. But historically, y'all have done extremely well, and I'm looking forward to what you do.
Well, thank you very much for your time, and we know you're quite busy, so let's thank the author.
Yep. Thanks, everybody.